Common interpreters in web-based applications. Most web-based applications have interpreters on the client, the server, and the database. The primary interpreter in a traditional web-based application is the browser, which is responsible for evaluating HTML, style sheets, and JavaScript. Injection attacks on the client side are so common that they have their own special vulnerability category, cross-site scripting. On the server side, one common interpreter is the operating system itself. If untrusted user data is concatenated to a statement that is evaluated on the command line, then the application has what is known as a command injection vulnerability. The most common used interpreter used by virtually every web application in existence is a database. Developers interact with databases through use of the structured query language, also known simply as SQL. Injections through SQL are common in web applications, easy to exploit, and if exploited, can have a devastating impact on an organization. Regardless of where the interpreter may exist, the attack pattern is the same. An attacker supplies input containing both data and commands. The application neither validates nor encodes the untrusted data to ensure it is safe, and the application is tricked into passing those attacker-controlled commands to the interpreter for evaluation. Code-level defenses to prevent SQL injection. Clearly, SQL injection can be used to carry out some serious attacks. So how do we go about mitigating this risk at the code level? In the case of numeric values, input validation and explicitly parsing numbers to numerical values will indeed stop SQL injection. However, in the case of character fields, input validation alone may not be sufficient to mitigate the risk. Fortunately, most development platforms contain a built-in way to protect against SQL injection. In order to prevent the attack, we make use of variable binding through query parameterization. Variable binding allows the application developer to pre-compile the SQL command before applying attacker-controlled input. Since the interpreter has already pre-compiled the SQL command, it cannot be tricked into interpreting any special characters that may be included in the attacker's input. Variable binding applies to all types of SQL statements, including select, insert, update, delete, as well as any database-specific calls. Variable binding using query parameterization can be used to mitigate the risk of SQL injection when invoking stored procedures. But did you know that your stored procedures themselves may dynamically construct and evaluate SQL commands? Therefore, it is imperative that we apply variable binding through query parameterization within our stored procedures as well.
Due to the complexity of building a solid encoding routine, you should not attempt to develop your own encoding algorithm. There are many security edge cases that need to be factored into an encoding algorithm, so it is preferable to use a vetted library. One of the best encoders used for Java EE applications is the OWASP Encoder project, which has high-performance encoding algorithms for a variety of common contexts. These encoders can be used directly within the JSP. For example, we make use of the encode for HTML attribute value encoder on the input tag, and the encode for JavaScript block encoder for the JavaScript variable declaration. There are other contexts available. For more information on the most recent version of the encoder, please view the source at OWASP. ASP.NET performs auto-validation and auto-encoding on a number of web form elements. However, developers can manually output encode when necessary, either using the built-in server.html encode method or through use of the anti-cross-site scripting library. In the event of manual output encoding, developers are encouraged to make use of the anti-XSS library as it includes vetted encoders for many of today's web contexts.